Okay, for this next question for test 3, part 1, we need to find the magnitude of her recoil velocity if she throws the wrench. So that's the first thing we need to find. So in order to solve this, what we need to do is find VAX. So VAX stands for the velocity of the astronaut, and this X stands for in the X direction. So what we need to find first is the velocity of the astronaut in the X direction. So let's go to solve that. So we have VAX, and this is equal to negative 1.0 kilograms times 10.0 meters per second over 2.0 times 10 to the 4th kilograms meters per second. So now this is a simple equation to solve. It's just subtracting, multiplying, and dividing. So we'll have that this is equal to negative 0.10 meters per second. So this that we just solved, this is the astronaut's velocity after throwing the wrench. Now the next thing we need to find is the time it's going to take the astronaut to get back to the spacecraft before she runs out of air. So what is the time that it will take her to get back to the spacecraft? So for this problem, for this next question, we need to use the equation that X is equal to velocity times time. This is a times multiplied. Oops. So using this equation, we can manipulate it to solve for t, to solve for the time. So we'll have that t is equal to 100 meters, which this is how far she is from the ship, divided by 0.10 meters per second. So this is also very simple to solve. This is also equal to 1.10 to the 3rd seconds. So when we solve this, we'll see that t is equal to 16 minutes and 40 seconds. So this is how much time it will take the astronaut to get back to the ship if she goes at a constant velocity. So that's how you solve example 8.2.